Welcome back to the night class. All right, 11-2. I'm Coach Knight. We are comparing data sets. Now, what were the three data sets we just kind of learned about in the first lesson? Box plots, histograms, and dot plot. Dot plot, box plot sound very similar. Okay, so example 1. We are comparing dot plots. Okay, so let's compare dot plots. Let's see. We're basically making sure we can read these things. All right. Sawyer has narrowed his car search down to 2 different types of cars. To make an informed decision, he gathers data on estimated highway fuel efficiency of the 2 different types of cars. The dot plot shows the data for each type. So if you notice, old Sawyer, still worrying about this car, and it's gas. He's got 2 types. Everybody agree? All right, so type 1, what do you notice about it?
It's very consistent together.
It's a little, they're all kind of clustered real close, okay? Type 2 is a little more spread out. Everybody agree with that? I agree too. Let's see. It says, Part A, if highway fuel efficiency is the most important feature to Sawyer, which type of car should Sawyer purchase? Type 1 or type 2? Why do you say type 2? Because most of type 2 have better fuel efficiency.
Why is the dude so worried about fuel efficiency?
Money, honey. Well, if you have it, you ain't got to worry about it. But, you know, us po folk, it matters, okay? All right. So, that's right. I can't afford the R or the L. It's po folk. It's just whatever. All right. Y'all are excellent. Okay. It says, y'all listen. The data display suggests that type 2 cars have better highway fuel efficiency. The data for type 1 cars are clustered from 33 to 38, and the data for type 2 cars are clustered from 35 to 44. So based on the data displayed, Sawyer should purchase a type 2 car. All right? For the next one. Same process, part B though, says Sawyer wants more information about the fuel efficiency of each type of car. So he calculates the mean and the mean absolute deviation. That stands for mean absolute deviation, short for MAD. Okay? Mean absolute deviation of the 2 data sets. How can these measures help him make more informed decision? All right, so first off, the mean is just the what? It's just the average. Went too far. Where did it go? There it is. Okay. So, the mean is just the average. Okay? You can get the average just by putting it in your calculator in that second, and it's the very first one. Okay? The mean fuel efficiency of type 2 is how much? 40.25 miles per gallon. Type 1 cars are 35.75 miles per gallon. So definitely still going with type 2 if we're just looking at the mean. Okay? The next one, the mean absolute deviation. It is the mean of the differences between each value in a data set and the mean of the data set. All right, so what does that mean? Differences. What are we doing when we're finding differences? Subtracting. And so we're subtracting the value of each number in the data set minus the average. Okay? So just to be, if the average is 50 and one of the numbers in the data set is 46, how far is 46 away from 50? 4. Okay? It's called absolute because you always take the absolute value of whatever the difference is. Okay? So you're literally wanting to know how far are they away. It doesn't matter if it's above it or below it. That's what they're talking about. Y'all ever said, hey, you know, when are you going to be ready? I'll be ready in an hour, give or take or 2. You know, give or take 1. All right? Have y'all ever heard that? Somebody say give or take? That means, you know, if it's, I said 1. I should have said, it could take 6 hours, give or take 2. That means it's either going to take between 4 hours to 8 hours. Okay?
heard
Sounds
the phrase
like-
give or take.
I've heard give or take, but I've not heard give or take.
I've heard give or take.
I'm just saying give or take too.
Yeah.
All right. So there is a calculation that has to be done to get the mean absolute deviation, and it takes a little bit of calculating. Okay. So first thing, here are our data points: 33, 35, or 34, 35, 36, 37, 38, 41. Now, notice we didn't write each one down how many times they happen. We just wrote the number and then put over here how many times it happens. Okay? So the mean we already got for type 1 was 37 or 35.75. Okay, they already told us that. Okay, we didn't actually find it. They told us in the problem. So we subtract 33 minus 35.75. That's 2.75. Does everybody see how I'm getting that? Now, technically it's negative 2.75, but we're taking the what of it? The absolute value of it. Okay, so you're not going to have any negatives on here. All right? So once you get the differences, how many times did we have 33? Twice. So how many times are we going to have this difference? Twice. So you multiply that by 2. Okay? Plus, how many times did we have 1.75 as a difference? 3. Plus, how many times are we having 0.75 as a difference? 3. Okay? And you keep doing that for all of them. All right?
Teachers, please release ROTC students.
They leave like every
Where do they go?
They go to Moss Point.
Yeah.
It's every day.
They go to Moss Point for RTC. All right.
Van Cleve is VOTEC.
So we do that for all 1, 2, 3, 4, 5, 6, 7 of our differences. Like I said, 33 happens twice, 34, 3, 35, 3, 36, 3. And so we're multiplying those differences by how many times they happen. We get that number, and we divide that by how many there are. How many numbers were there total? Do y'all remember?
Not really.
There were 16. Okay? If you forget, you can just add these numbers up. 2 and 3 make 5, 8, 11, 13, 15, 16. Divide that by how many there are. That is your MAD. That is your mean absolute difference. Okay?
Equal signs.
Does anybody know what that little funny equal sign means?
Approximately.
Approximate. So we did what to this decimal? We rounded it. Okay? They round. Anytime you see that little squiggly, wavy looking equals, that means it rounded. Okay? So it says use a similar process to find the MAD of type 2 cars. The MAD of type 2 cars is about 2.94. So I want you to understand this. Okay? Madison earlier said that they were more spread out, right? And the first ones were a little more closer together, a little more closer cluster, okay? This is what the MAD tells you. Notice, what's the MAD of type 1 cars? 1.63. That's not very much. The MAD of type 2 cars is what? 2.94. Basically, what the MAD is telling you is how spread out are they, okay? So type 1 was spread out quite a bit, and type 2 not so much. Again, here they are again. Type 1, I said that backwards. Type 2 is spread out more than type 1. See how they're all kind of clustered? Okay? But what does that mean in my purchasing part?
More reliable. More consistent.
I'm more reliable to get what? A type 1. If I buy a type 1, that means I'm pretty for certain sure it's going to be between 34 and 36, at least, gas mileage, okay? But for here, it could be all the way from 35 to 44, really, and it's kind of like taking a chance. I might get the 44, but I might get the 35, too. Is that making sense?
But the lowest is still
35 is good. The lowest is, that's correct. So I still, even though the mean absolute deviation is more, I still probably would go with type 2 because it doesn't really affect which one's going to be the better gas mileage. Does that make sense? But it could have.
Oh, I thought you were saying we were going type 1. I was like, dude, that don't make no sense.
No, we're still going with type 2. But just understand, the MAD is telling you, hey, type 2 is a little more spread out, so there's less chance that you'll get a car that you really want. Is that making sense? Okay? All right. Is that, nope, we got one more. Here we go. How does the outlier in the second data set affect the mean and MAD?
Makes it easier.
Does it make the MAD go up?
Yes.
It does. Again, the further this is away, the bigger the difference between that and the mean, correct? Okay, so it would make both of them increase. Okay, that's all you'd have to put there. All right, so there's dot products. Let's compare. I said dot products. Dot plots. That's like
It's like a new
and
brand.
that's it's advanced math plus actually there is something called a dot product when you're talking about vectors, and so I'm getting
What? Vectors.
I thought Vector
Exactly.
was a robot off of iReady.
no vector is a villain in Despicable Me. Okay,
That's Victor.
his name's not Victor. His name is Vector.
He had a whole thing on
Yeah, with his little piranha gun.
Exactly. Piranha gun. Vector
And he
with direction and magnitude. Anyway, okay. Oh yeah. All right. Here we go. No. Back to work. Caitlin and Philip go to neighboring high schools and both are sponsoring charity fundraisers. Shh, y'all listen. Caitlin claims that students at her school are raising more for charity than the students at Philip's school.
It shouldn't be a competition. They're raising money for charity.
The amount, yeah, everything's a competition. The amounts raised by a random sample of 30 students at each school are shown in the box plot below. Do the data support Caitlin's claim? So here's Caitlin's claim. Here's Philip's claim. Caitlin's claim, what's the median donated? 40 looks like 45, okay? What is the median in Philip's?
152 or 49.
Looks right at 50, okay? So, what's that mean? That means half of the people at Caitlin's school gave $45 or more. Half of the people at Philip's school gave what? $50 or more. So which school's actually Philip's is doing better? Okay? Philip's is doing better. All right. How does the IQR, what's that stand for? Interquartile range. That's the range from Q1 to Q3. Okay? That's where the 50% of the data is in that range. Okay? So, how does the IQR, the interquartile range of the money donated, compare to the range for Caitlin's school and Philip's school? So, this interquartile range for Caitlin's school goes from what? 32 to 52. So that's how much?
10, 20.
That's 20. 32 to 52 would be 20. And Philip's school is 45 to 1, 2, 3, 4, 5, 6. Looks like 45 to 56. What would that be? 11. So the IQR for Caitlin's school is 20. The IQR for Philip's school is 11. And what does that mean? That means 50% of the students are giving within $20 of each other at Caitlin's school. 50% in Philip's school are giving within $11 of each other. Okay? So that's all that means. How does it compare? So who has the bigger IQR? Caitlin, but that just means they're more spread out. The giving is more spread out. Okay? Philip's.
That's what Christmas season is all about.
Exactly.
Halloween and
Tis the season to be merry. Okay.
it's the season to be spooky.
All right. Compare histograms. Here we go. Marketing team compares the ages of a random sample of 30 viewers of 2 popular news shows to decide which product to advertise during each show. During which show should the marketing team advertise a product that is targeted at adults aged 20 to 29? So this is show 1. This is show 2. So, how many, this one's kind of a, it could, well, let's talk about it. 20 to 29, how many people are watching it? 8. 20 to 29 is 8. Everybody see that? What about show 2? 20 to 29. got how many here? 3 and 5. 3 and 5 make 8. So they're both 8, but I would still rather have which show and why?
The second one, because it's both.
Very good. I would still rather have show 2 because in show 2, I'm getting a little bit of each age range. Okay? In show 3, I didn't have any 20 to 24, or show 3. In show 1, I didn't have any in 20 to 24. Okay? I just had 25 to 29. I had 9. I had a lot. But my range I'm looking at is 20 to 29. Okay? So I want to have at least a few in all of those. Does that make sense? So even though they both add up to 8, I'm going with show 2 because of that. Does that make sense? All right.
Coach Stone, I can't wait until there's like questions in a few years that you go to high school. COVID-19 has 4 different classrooms. And this classroom that had 4 students has
It's coming. Might be next year. Number 3, based on their sample of 30, if the marketing team wants. Okay, now we're doing target 25 to 34. So 25 to 34 is how many? 18 for show 1. And 25, well, that's not very much at all. That's what, 5 and 9? So we're going to go with 18 or we're going to go with 9?
That's a toughie.
I think I'll go with 18. I think that one's definitely a show 1. Okay? Any questions on how to read these? Everybody's good? Beautiful. All right. Which one are we going to use here? Oh, it says, how could you use a box plot to compare the data that she collected? So box plot means we need to find the what? Box plot. What do we got to find? 5 things. Median in the middle, not the mode. Q1, Q3, max and min. Okay? So thankfully it's already done for us. I know, right? So here they are, already found. They even showed us the interquartile ranges. That was sweet of them too. There's my 2 box plots. Okay, now we're talking about the average number of texts sent, right? What'd you notice on non-school days? It's a little more, okay? Imagine that.
Not like those 8 hours.
Seriously, what else you gonna do? Read?
Ew.
Exactly.
Who does that?
All right, so here it says students send far more text on non-school days than on school days. There is more variation on the number of texts sent during non-school days than on school days. And one person does not send any text on non-school days. This represents an outlier. Again, look how far it is. See how big my whisker is? Yeah, that is very depressing. Somebody just doesn't have no friends. Or maybe they don't have a phone. That could be it too.
That would be really sad too.
That is sad too. All right. Part A. Says provide a possible explanation for the observations made about Nadia's data about her classmates' texting habits. So, here's the observations she made. She said students send far more texts on non-school days than on school days. Was that true? Yes. Why would that be the case? Because they're busy on school days, right? You got school, you got sports, band, you know, homecoming, whatever. All right? Why would there be more variation in the number of texts sent on non-school days than on school days?
Because on non-school days we're just bored out of our minds. Non-school days
People get grounded. Excellent. Okay. That's true. Okay. It still happens, right? You might be grounded. This Anna Claire's answer might work for this one too. One person does not send any text on non-school days. What might have happened? They might have been grounded. Beautiful. Y'all are getting it. Okay. It says make 2 more observations about the data that Nadia collected. So what else could we say?
Nobody texted over
How about here on school day? On school day, 50% of them send from what to what? Text. Not 0. That's not 10. 9 to 22. So 50% of them send between 9 to 22 texts during school.
Could you still say 0 to the mean? Can you not say 0 to the mean? Is 50%?
Yeah, but yes, you could. I was about to say no, but yeah, you can. But just know that's what the box is telling you. The box is telling you this is the main like meat of the argument. Okay? I know that's a bad word. All right. How about for non-school days? We're going between what and what?
I can't really.
40 to 60. Okay? That's not.
I don't send that many.
There's only 24 hours in a day.
That's a lot.
That is a lot per day.
Anybody that much unless it's
All right. There's, like I said, there's our little review. We are done. Have a great day. We'll see you next time. As always, stay above the line.